One.
Hello, this is Unit 3, Essential Question 3 video here. And in this video for today, I'm going to focus on the top two red objectives, and they are that I can explain what a mole represents, and I can also calculate the formula mass of a given substance. I will talk later about the last two objectives here for this essential question later in the week, but for right now, I'm just going to focus on the top two red ones. So, first of all, when we look at relative mass scale, that just looks at, just in general, when we want to try to count the number of atoms that we're looking at for a particular compound, we all know that atoms are extremely small. And so it's fair to say that 10 grams of hydrogen does not contain the same number of atoms as does 10 grams of lead. Because clearly, if you go look at the periodic table, you will notice that the hydrogen's average atomic mass is way different than the lead's average atomic mass. So we came up with this relative mass scale so that it could make it possible for us now to be able to count how many atoms are possible within a measurable kind of mass. And so we base it around this concept of what's called a mole. And a mole was discovered by a gentleman of Amadeo Avogadro, which you can see his picture down in the lower right corner. And it's coming from the basis of we want to be able to count different units, or we want to be just essentially just have a counting unit. So we all know that if you were to go to your fridge and I said, grab out a dozen eggs, we know that you would be coming back with 12. If I said, everyone's wearing a pair of socks today, that we would know that everyone has 2 socks. And if I said, go to the office and go ask them for a ream of paper, that you would be coming back with 500 sheets. So those are just simple ways of counting. So rather than always, like, especially with the ream of paper example, is instead of counting every single sheet individually, it's a lot easier just to simply go to the office and ask them for 2 or 3 reams of paper right away instead of having them count out 15 or anywhere from 1,000 to 1,500, depending on what you need. It goes a lot faster. So that's where this idea of the mole is coming in. And so it's just a standard unit for us to look at the amount of different substances. And so the abbreviation for mole is coming MOL. They just made it simpler by taking the E off. And it looks at how many particles are there within a 12 grams of carbon 12. So they focused a lot of their discovery around the structure of the carbon 12 atom. And so Avogadro's number, like the vocab word that you have hopefully already looked up, you'll notice that you hopefully have seen this number, 6.022 times 10 to the 23rd. And I have that cute little picture up on the top because oftentimes when people hear the word mole, they think of that animal. And just a quick little side fact, if you recall, Pi Day has its day on March 14. Mole Day does in fact exist, and it occurs on October 23rd. So if we were able to have gotten to this topic back in October, there might have been a chance we could have celebrated perhaps a little bit of Mole Day. But given the context of where we weren't able to honor the day. But so going back to what exactly is Avogadro's number. So like I said, it's coming from the discovery of basing the information from the 12 grams of carbon 12. And he noted that it was 6.022 times 10 to the 23rd atoms. Well, oftentimes people will probably want to look at like individual atoms. They might want to look at the number of molecules. They might perhaps want to look at different formula units. So with all those different variables, they came up with the second bulleted statement that it is 6.022 times 10 to the 23rd particles equals 1 mole of a pure substance. And that, for sure, ladies and gentlemen, I'd like for you to please jot down. Particles could represent atoms, it could look at molecules, it could look at formula units. And so when we look at later on in this particular essential question, when we get to solving using dimensional analysis, we'll want to make sure that instead of the word particles, that we're actually giving a specific unit behind that number. So if we were to say we have 1 mole of ethanol, it is fair to say that in fact we have 6.022 times 10 to the 23rd molecules, therefore, of ethanol. So the last statement, and I even put an exclamation point behind it because it stands true, that 1 mole of anything contains 6.022 times 10 to the 23rd anything. So if you right now could please grab out your periodic table and then also have a calculator available, that will be super helpful for when it comes now for the rest of the notes here for this first part of the essential question 3. So pause the video, grab what you need, and then push play again. All right, so what do we have here in terms of molecular mass? So if you go look at your periodic table, find the element of boron, number 5, has the atomic number, so which means we have 5 protons, 5 electrons. That decimal number that is included on the periodic table is the average atomic mass for that particular element. And so I have it here circled in red, so 10.811 is the average atomic mass for this particular element. So if you recall, what exactly is an isotope? An isotope is where we have naturally occurring element that has a different number of neutrons. And so when we try to average the 2 isotopes that occur for boron with a mass of 10 and boron with a mass of 11, that the boron mass of 11 found out in nature is going to occur at a much higher percent than, say, boron 10. And we can easily determine that based upon the fact that the average atomic mass is 10.811. Now, the unit that goes behind that particular number is what's called the atomic mass unit. It has an abbreviation of AMU. So what exactly is an AMU? So it is exactly 1/12 the mass of a carbon-12 atom. Again, when Avogadro was working with the concept of a mole, he was focusing on this particular element of carbon-12. And so mathematically, that would come out to be 1.66 times, or 0.65 times 10 to the negative 27th kilograms. That's really tiny. So there has to be a way, somehow, can we correlate this concept of atomic mass units to looking with Avogadro's number? And in fact, there is. And so before I click on to the next slide, I will ask, if you haven't already jotted down the average atomic mass definition, please make sure to do so, because I just want to make sure that everyone remembers that when we look at that word or that definition, that we're looking at that it's the weighted mixture of naturally occurring isotopes. So when we look at the concept of the mole and looking at it in terms of a pure substance, so we have the fact that the mass of 1 mole of a pure substance is going to be called the molar mass of that substance. And we'll give it a unit of grams/mole, so grams over mole. And what's really nice is that the concept of the molar mass is numerically equal to the atomic mass in AMU of any known substance. So if we were to look at the atomic mass, say, of oxygen, so if you find oxygen on your periodic table, I believe it's number 8, it should be 15.999 AMU. And then the molar mass of oxygen would be 15.99 grams per mole. And then likewise, if you look at calcium, which is number 20 on your periodic table, you'll see that it has an AMU of 40.078, and then the molar mass also happens to be 40.078. The only thing that's different would be the units.